Hello guys, today we're going to learn about aldehyde and ketone. You may not know it, but you have already experienced aldehyde and ketone based on things you have likely smelled and tasted. Vanillin, for example, is responsible for the smell of vanilla, where almond flavor results from benzaldehyde, cinnamon from cinnamaldehyde, and spearmint from carbone. Odors and sensations that are far less pleasant can also be caused by aldehyde and ketones. For example, the pungent odor of formaldehyde or acetone, or the hangover caused by acetaldehyde that results from drinking too many alcoholic beverages. We'll learn about the general formula of aldehyde and ketone. Aldehyde have carbonyl group bonded to a carbon atom on one side and a hydrogen atom on the other side. For ketone, they have a carbonyl group bonded to both a carbon atom on both sides. Next is we're going to learn how to name aldehyde and ketone. Aliphatic aldehyde is named in substitutively in the apex system by replacing the final E of the name of the corresponding alkane with al. For example, hexane is an alkane. If it is an aldehyde, it will be called a hexanol. Since aldehyde group must be at the end of the carbon chain, there is no need to indicate its position. When other substituents are present, the common group carbon is assigned position number 1. Many aldehydes also have common names which are derived from the common names for the corresponding carboxylic acids, and some of the names are retained by the IUPAC as acceptable names. For example, methanol as formaldehyde, ethanol for acetaldehyde, propanol for propanaldehyde, and phenylethanol as phenylacetaldehyde. Aldehyde in which the functional group is attached to a ring system are named substitutively by adding the suffix carbaldehyde. For example, zinc carbaldehyde or benzaldehyde, cyclohexane carbaldehyde, and 2-naphthalene carbaldehyde. Naming for aliphatic ketone is just the same as aldehyde, which is by replacing the final E in corresponding alkane with O and E O. The chain is numbered to give the carbonyl from the lowest possible number, which will designate its position. Common functional group names for ketones are obtained by separately naming the two groups attached to the carbonyl group and adding the word ketone as a separate word. For example, pen for N2-on can also be called as allyl methyl ketone. Some ketones names are retained in the IUPAC system, such as acetone, acetophenone, and benzophenone. Functional group of a ketone act as a prefix. When it is a prefix, it is called a functional substituent. For example, carbonyl atom attached to hydrogen will be called metanoil or formyl group, and for a carbonyl atom which is attached to a methyl will be called ethanoil or acetyl group. And also finally, if the carbonyl atom attached another alkyl group, it will be called alkanoil or acyl group. For example, you can see from 2-methanol benzoic acid, orthoformyl benzoic acid, which is its common name, and 4-ethanol benzene sulfonic acid, also called as para-acetyl benzene sulfonic acid.
The history of aldehydes. One of the oldest aldehydes was first produced in 1774 by Carl Wilhelm Scheele, although its structure was not completely understood. In around 1835, the structure of aldehyde was determined by German chemist Justus von Liebig. Justus von Liebig determined the constitution of aldehyde, described its preparation from ethanol, and gave them name aldehydes to the chemical group. The history of ketones. Ketones were first discovered in the urine of diabetic patients in the middle 19th century. For almost 50 years thereafter, ketones were thought to be abnormal and undesirable byproducts of incomplete fat oxidation. In the early 20th century, they were recognized as normal circulating metabolites produced by liver and readily utilized by extrahepatic tissue.
Aldehydes and ketone can be prepared using a wide variety of reactions. There are three types of synthesis of aldehyde, which is hydration of an alkyne, oxidation of primary alcohol with PCC, and reduction of an ester, acid chloride, or nitrile. And for synthesis of ketones, there are four types of reactions that can be used to form ketones, such as oxidation of secondary alcohol, Friedel-Crafts acylation, hydration of an alkyne, and reaction of Grignard reagents with nitrile.
Reaction of aldehydes and ketones. Aldehyde and ketones undergo a variety of reactions that lead to many different products. The most common reactions are nucleophilic addition reaction, which lead to the formations of alcohol, alkenes, diols, cyanohydrins, and imines. The general mechanisms of nucleophilic addition reactions of aldehyde and ketone is shown below. The first reactions is the hydride, for examples, which is sodium borohydrates or lithium aluminum hydroxide, which forms the alcohol as the products. Second is the reactions of aldehydes or ketones with alkyl lithium, which produce alcohol with C to C bond formations. Third is the Grignard reagents, which produce the alcohol. And next one is the alkylate anion, which form alkynyl alcohol. Last is the reactions of aldehydes or ketones with cyanides, which forms a cyanohydrin compound.
Aldehyde and ketones find application in different sectors such as pharmaceutical, food, fragrance, and cosmetics because of their chemical properties. One of the most extensively used for ketone is acetone. Ketone behave as an excellent solvent for certain types of plastic and synthetic fibers. Besides, it's also used for medicinal purposes such as chemical peeling procedure as well as acne treatments. However, in perfume, ketones are used to create acetophenone, which produce almond, cherry, honeysuckle, jasmine, and strawberry fragrance. Compared to ketones, aldehyde are more popular source for perfume fragrance. Some perfume containing aldehyde include Chanel No. 5 and No. 22, Lancôme and Estée Lauder. Furthermore, certain popular flavors of baking such as cinnamon, vanilla during baking are because of aldehydes. Aldehydes are also present in herbs such as coriander and give it the characteristic smell of coriander.